Hello everyone, I would like to introduce you to the HVAC Climate Chamber project. Our project team includes Anzi Zhu, Isaac Corona-Quiles, Hugh Gabbert, Raimundo Calderon Robles, and myself, Michael Leon. The purpose of our project is to control the dry bulb temperature and humidity of a 6-foot by 7-foot by 8-foot climate chamber for the Civil Engineering Department. Dr. Jansen of the Civil Engineering Department used the climate chamber to treat concrete samples for labs, but the existing equipment stopped working properly. We stepped in to remedy this problem and improve the climate chamber as best as possible. Our approach included installing new equipment such as heaters and humidifiers, painting with mold-resistant coating due to high humidity, and overhauling the entire data logging system. Our group was nearly finished with this project until the unprecedented dismissal of students from campus prevented us from fully completing it. Now the project is intended to be handed off to next year's senior project group for completion. This presentation will go over design requirements, equipment selection, the climate chamber setup, the controller, and next steps. Thank you.
The design requirements for the climate chamber are set to meet the Civil Engineering Department's needs for concrete specimen storage. The concrete specimens will be stored in the chamber and maintained at 73 plus or minus 3 degrees Fahrenheit with a relative humidity of 50 plus or minus 4%. The samples will remain in the chamber for extended periods of time, possibly several years, and data must be logged for the storage duration.
In order to maintain climate control inside the chamber, we ordered a few pieces of equipment. We use a 500-watt heater for the heating load and an ultrasonic humidifier for the humidifying load. A residential dehumidifier will be used for the dehumidifying load. Additionally, temperature and humidity sensors measure the temperature and humidity adjustments that need to be taken by the control array. The chiller from the old climate chamber will be reused. Dr. Poiker wanted an additional goal of using the climate chamber to test an atmospheric water condenser. In order to maintain the environmental humidity and temperature, the equipment needed to remove 900 watts of heat and humidify at 2.5 liters per hour. We also wanted an added flexibility with a larger temperature range. Therefore, we bought a 5 liter per hour atomizer humidifier and a pair of humidifier floats. The atomizer unit will be placed inside a 20-gallon storage container that is partially filled with water, and a waterproof fan and mesh are placed on top of holes cut in the lid to encourage airflow.
So the climate chamber is a 6 by 7 by 8 foot room with a door, a window, a concrete drying rack, and a table. So on this table, we're going to put the dehumidifier and the humidifier, and it's also where the AC outlet comes from in the corner. And along the walls, we're going to have some space heaters, a fan, and a sensor. So all this equipment is going to be established away from the concrete drying rack. That way, none of the samples get hit directly by some of this treated air. And the temperature and humidity sensor is going to be placed right next to the concrete drying rack. That way, we can get an accurate measurement of what the air is like near the concrete samples.
The control panel contains the CPCO, a Corel programmable logic controller which can be programmed and set up in numerous ways to control a wide variety of equipment while reading analog or digital parameters. The unit was kindly provided by the helpful team at the West Coast Corel office. The controller has been set to read temperature and relative humidity from the Senva sensors located next to the samples and will use on-off control to cycle the necessary equipment and maintain the desired conditions.
The outlet panel is a second, smaller control panel. This panel sits adjacent to the main control panel and contains 11 outlets and a breaker switch. Each outlet controls a different piece of equipment and uses relays from the main control panel to turn equipment on and off appropriately. Knockouts and proper conduit can be used to connect it to the main control panel.
Since we weren't able to complete this project without being in person, the next step involves applying a second coat of paint to the chamber to protect it from high humidity conditions, installing equipment such as space heaters, fans, and temperature and humidity sensors, and then running the equipment alongside the control panel to ensure that the system can control the chamber properly. These tests will be run over the course of a few weeks, logging temperature and humidity data to ensure that the chamber is running properly.